Hi, my name's Colin. In this module, we're going to find the equation of a straight line through two given points. The question we posed is the following. Given the 2 points 1, 1 and 2, 3, find the equation of the straight line that goes through both these points. Well, first and foremost, the equation of any straight line can be written in the form y equals mx plus b. Now, the constant b represents where the line cuts the y-axis. We call this the y-intercept. Here, we can see from our graph that this is -1. The constant m represents the gradient, or the slope of the line. This tells you the steepness of the line, and more generally, its direction, and is measured by a ratio commonly called rise over run. Here, if you run 1 unit across horizontally, the line has risen 2 units vertically. So, for our rise over run ratio, we have 1 for the run and 2 for the rise. Thus, our gradient m is the constant 2. Now, the gradient, defined by the ratio rise over run, effectively tells us how quickly the y values are changing with respect to the x values. Here, the gradient of 2 indicates that the variable y is increasing twice as quickly as x. This notion of the rate of change of one variable with respect to another will be of utmost importance when you begin your studies of the differential calculus, one of the core topics of this unit. In fact, calculus is often precisely thought of as the mathematical study of change. In summary, the line that passes through the points 1, 1 and 2, 3 has the gradient or slope 2, and y-intercept -1. Thus its equation is given by y is equal to 2x minus 1. Now, it's very important to realize that we found the gradient m and y-intercept b by relying heavily on a good sketch of the graph. However, for difficult lines, it can be very hard to take accurate measurements of m and b just by observing a graph. Thus, it's very important to be able to work out the equation of a line without having to rely on a sketch. So, let us now go back and show you how to find m and b algebraically. Now, with the algebraic method, you should always find the gradient first. So let's do that now. As we know, the gradient m is defined to be the ratio rise over run. Now, if I call one of the points x1, y1, and the other point x2, y2, then we can observe that the run is simply this distance subtract off this distance, which is just x2 minus x1. And the rise is simply this distance subtract off this distance, which is just y2 minus y1. This gives us a general formula for finding the gradient of a line passing through 2 points labeled x1, y1 and x2, y2. Now, substituting in our numbers, we get 3 minus 1 for the rise and 2 minus 1 for the run, which simplifies to just 2, confirming what we know from earlier. In case you're wondering, it doesn't actually matter which point you label x1, y1. You should get the same gradient at the end of the calculation, provided you apply the formula correctly. Anyway, we now know the gradient of the line, so the formula y equals mx plus b can be updated to y equals 2x plus b. All that remains for us to do is to find the y-intercept b. How do we do that? Well, any point that's on the line must satisfy the equation of the line. Thus, we can grab one of the 2 points given to us and substitute it into the equation y equals 2x plus b, which will then give us an equation for b. Here, we'll choose the point 1, 1 to substitute in. So, by setting y to be 1 and x to be 1, we therefore get the equation 1 is equal to 2 times 1 plus b, which simplifies to just 1 equals 2 plus b. Subtracting off 2 from both sides, we therefore get b to be negative 1. Therefore, the y-intercept is negative 1, confirming what we know from earlier. Hence, this time, we found the equation of the line without having to sketch or read off a graph. Now, there is a second common method used to find the equation of the line once you've found the gradient. This method involves using something called the gradient point formula. Which is useful when you know the gradient of the line and a point on the line. The formula states that the equation of the line is the following: y minus the y value of the point on the line is equal to the gradient of the line, which you found earlier, times x minus the x value of the point on the line. Here, we know the gradient is 2, and using the point 1, 1, this is therefore 1, and this is therefore 1. Thus, the equation of the line is the following. The equation can then be rearranged into the mx plus b form above by first expanding the right-hand side and then adding 1 to both sides. So in summary, to find the equation of a line given 2 points, you should always first find the gradient. You can then either substitute a point into the updated mx plus b formula and then solve for the y-intercept b, or you can use the gradient point formula. One final thing, just to be complete. You should be wary of special lines that are exactly vertical. These lines are special in the sense that you cannot write them in the usual form, y equals mx plus b, and will instead come in the unconventional form, x is equal to some constant. Alright, I hope you found that useful. See you next time.